In this lesson, we are going to look at the inverse and the contrapositive of conditional statements. Our goal is to understand and interpret the contrapositive and the inverse of a conditional statement. The inverse is a statement that is formed by negating both the hypotheses and the conclusion of a conditional statement. For example, for the statement, if a number is even, then it is divisible by 2. The inverse is, if a number is not even, then it is not divisible by 2. So negating both of them means placing the word not in the hypothesis and the conclusion. And you now have the inverse. The contrapositive is a statement that is formed by negating both the hypothesis and the conclusion of the converse of a conditional statement. Now remember, the converse was when we switched the hypothesis and the conclusion around. All right, so now we're going to negate those. So if the statement is if a number is even, then it is divisible by 2. The contrapositive is if a number is not divisible by 2, then it is not even. Let's just have a look at what happened here. So we have our conditional statement. We're talking about a number being even and it being divisible by 2. Now, in a contrapositive, we're going to put the word not in front of each of these statements, but we also have to flip these statements around to make it the converse. All right, so as you can see, the divisible by 2 now becomes the if part, and then we add the word not. The number is even becomes the then part, and we add the word not. So in a contrapositive, you are placing the word not into both the hypothesis and the conclusion, but you are also flipping the order of what is said in the statement. So let's look at this conditional statement. If you live in Prince Albert, then you live in Saskatchewan. Is this a true statement? Well, yes, it is. Prince Albert is in Saskatchewan. So if you live in Prince Albert, then you live in Saskatchewan. Write the converse of this. So remember now, converse is what we looked at in the previous lesson. Converse is switching the hypothesis and the conclusion. So we're going to switch these statements around. If you live in Saskatchewan, then you live in Prince Albert. That's the converse. All we've done is we've switched the hypothesis and the conclusion. Is this statement true? If you live in Saskatchewan, then you live in Prince Albert. Well, it could be true, but there's many, many, many counterexamples that take the absolute certainty of it being true away. It is false, and you could pick basically any other community in the province of Saskatchewan. So we could choose Birch Hills, we could choose Shellbrook, we could choose Yorkton, Saskatoon, Elbow. Pick any community in Saskatchewan. Now we want to write the inverse. Now remember, the inverse is taking the conditional statement and negating both the hypothesis and the conclusion. So putting the word not in there, taking the conditional statement. So it's this one, and we're going to rewrite it by negating the hypothesis and the conclusion. So if you do not live in Prince Albert, then you do not live in Saskatchewan. So that is the inverse. We've taken our conditional statement and we've negated both of them. We've said the opposite. So instead of living in PA, we do not live in PA. Now let's look at that and see if it's true. So if we do not live in PA, then we do not live in Saskatchewan. Well, that's false. And again, we can use the same counterexamples that we used up in B. Just because you don't live in PA doesn't mean you don't live in Saskatchewan. We might live in Shelburne. You might live in Holbein. You might live in Swift Current. There's lots of other places that you might live in Saskatchewan. Now we want to write the contrapositive. Now let's remember what the contrapositive is. The contrapositive is negating the converse. So we take our converse and we're going to negate that one. So we're going to say, if you do not live in Saskatchewan, then you do not live in Prince Albert. Is that true or false? Well, that one is true. If you do not live in Saskatchewan, then you definitely don't live in Prince Albert, because Prince Albert is in Saskatchewan. So hopefully you get the idea. Really what it comes down to is just remembering which ones work together. And then your inverse and contrapositive have the words not in them. In your logic notation, the inverse of if P then Q is written as if not P then not Q. And notice the symbols. All right, have a good look at what the symbols are. In logic notation, the contrapositive of if P then Q is written as if not Q then not P. Remember, because the contrapositive is of the converse. So we switch these around. So that's why the Q comes first and then the P. And we negate both of them. So it's not Q, then not P. Consider the following conditional statement. If a number is a multiple of 10, then it is a multiple of 5. We want to write the contrapositive of this statement. So remember, the contrapositive is the negation of the converse. So we are going to have to not only put the not in our statement, but switch the order of this statement. So now we're going to start with the multiple of 5. So we're going to say if a number is not a multiple of 5, then the number is not a multiple of 10. What we want to do is we want to verify that the conditional and the contrapositive statements are both true. So what we can look at, if we go back to looking at the first one, if n is a multiple of 10, all right, so if we write it out and we want to verify it, we can use an informal proof. And we can say if n is a multiple of 10, so that's any number. If any number is a multiple of 10, then this number can be equal to 10 times m when m is an integer. So basically, take any integer you want. Let's say we have the number 5. If we multiply that by 10, we get 50. N is a multiple of 10. Let's say we choose -3 for our m. That's an integer. -3 times 10 is -30. -30 is a multiple of n, or of 10. Now we can go further and we can say, since 10 is a factor of 10m, all right, it is a factor because we can divide that by 10, n is divisible by 10. So what we've done is we've shown that if you have a multiple of 10, it's divisible by 10. All right. Now we can go further and we can look at our multiples of 5. We can say also our number n, so same number, because it was equal to 10m, we can write it as 5 times 2m. 5 times 2 is 10. We are allowed to split up a number into 2 factors. Again, m is any integer. We also know that since 5 is a factor of 5 times 2m, and we know it's a factor because we can divide that by 5 evenly every single time. 5 is a factor of n. All right, so what we have shown is that if you have some number n that is a multiple of 10, it is also going to be a multiple of 5 because 5 is going to be a factor every time. So therefore, the conditional statement is true. So now we need to look at the contrapositive. Since all multiples of 10 are also multiples of 5, we just showed that, a number that is not a multiple of 5 cannot be a multiple of 10. So therefore, the contrapositive is also true.